Hi everyone, today's topic is speed of reaction. How we can measure speed of reaction? Reactant react at a particular time. What about the amount of reactant consumed at a particular time? That can be used to calculate rate of reaction. The speed of reaction can be obtained by measuring quantities of reactants or products at regular time interval. At regular time interval, what about the amount of reactants consumed or the products formed? Based on that, we can calculate rate of reaction. These quantities can be then plotted against time to give an overview of the speed of reaction at different times. Look at this diagram. In this beaker, conical flask, I took calcium carbonate and hydrochloric acid. Calcium carbonate react with the hydrochloric acid. We get calcium chloride, carbon dioxide and water. Here the carbon dioxide bubbles are coming out. When this carbon dioxide bubbles coming out, it reaches to this syringe and the piston will be moved back. The amount of gas collected at a particular time interval that can be calculated from this gas syringe, because when the carbon dioxide gas is released, the gas entered to the syringe and the piston moves back. Where there you can see there is some markings are there. Based on that, you can calculate the amount of gas collected. For a reaction that has a gaseous product, the speed of reaction can be obtained by measuring the speed at which gas is produced. For this, we took one example, hydrochloric acid react with the calcium carbonate. When hydrochloric acid react with the calcium carbonate, carbon dioxide gas is released and that carbon dioxide gas is collected in the syringe. If one particular reaction want to happen, there must effective collisions are there. Collisions are of effective and ineffective collisions. Those collisions leads to successful reaction. Such collisions are called effective collisions. All the collisions never come to an end of product formation. Certain collisions, they acquire particular amount of energy. Such collisions only leads to product formation. Such collisions are said to be effective collisions. Before a reaction can occur, the particles must collide each other, and those collisions are effective. That collision finally leads to product formation. When these particles attain a certain amount of energy, activation energy, then they collide each other. Successful collisions ultimately leads to the product formation. Now, we can discuss the factors that affect rate of reaction. The main factors that affect rate of reaction are concentration, pressure, this pressure case only for gases, particle size, that surface area, catalyst, temperature, light for photolytic reactions. The main factors that affect rate of reaction are concentration, particle size, surface area, catalyst, temperature, light, pressure for the cases of gases. Now we can discuss the main factors that depends on rate of reaction: concentration, particle size, that is surface area, temperature, catalyst, light and pressure. Pressure for gases. One by one we can discuss. First one, concentration. If the particles have a high concentration, the rate of reaction will be more. That is, if concentration is more, the rate of reaction also more. With a high concentration of reactants, the reaction will be faster. For example, you have dilute hydrochloric acid and concentrated hydrochloric acid. Take same quantity, 10 ml hydrochloric acid dilute and 10 ml hydrochloric acid concentrated. Add 10 gram calcium carbonate both, same time. So we took same amount of chemicals, but one is concentrated and one is diluted. Where the more gas will be released, obviously you can notice that will be released in concentrated. That is, concentrated, the particles are more, the solute particles are more, so the reaction will be faster. Next one, pressure. When we increase the pressure, the rate of reaction also increases. This pressure case only for the gases. For the gases, when we increase the pressure, the volume will be reduced. Due to the reduced volume, the particles must collide more rapidly. That means when we apply the pressure, the volume is reduced. When volume reduced, the particles are closely packed and the collisions are more, the effective collisions are more. Due to the effective collisions are more, the rate of reaction will be faster. So at a high pressure, the speed of reaction increases since the frequency of effective collisions is higher. That means more collisions are there when volume is reduced. When we apply high pressure, the volume reduced. Due to the volume reduction, the particles collide more. Due to the more effective collisions, the rate of reaction also increases. Next one, surface area or particle size. When you take the same reaction, hydrochloric acid, here we took both dilute hydrochloric acid, and take calcium carbonate lumps and calcium carbonate powder form, both 10 gram. All the required materials are in the same amount, but what we took, in one test tube we add lumps of, that is small pieces of calcium carbonate, and in one case we took powdered calcium carbonate. The powdered calcium carbonate will react faster because when we crushed or grind into powder form or small pieces form, the effective surface area will be more. So effective surface area increases, the particles get more chance for collide. Due to the more collision, the rate of reaction also increases. With a greater surface area exposed, there are more places for particles to collide. That means more effective collisions are there. Because of the more effective collisions or higher frequency of collisions are there, the rate of reaction become faster. Next one, temperature. Very similar or same method will be here also. As we increase temperature, the particles gain kinetic energy. Due to the increase in kinetic energy, the particles will move more randomly. Because of the more movement or the high kinetic energy, when we increase the temperature, then the particles collide more effectively. That means the number of effective collisions or the frequency of collisions are rapidly increasing. Due to the increase of higher frequency of collisions, the particles collide each other and the rate of reaction increases. The speed of reaction increases with an increase in temperature. At higher temperature, the reactant particles have more kinetic energy. They are then able to move faster and they collide more frequently because of the more effective collisions, and that leads to the reaction faster. Now, catalyst. What is a catalyst? Substances which alter the rate of reaction, which change the rate of reaction. They are said to be catalysts. Catalysts which speed up the reaction. What happens when we use a catalyst in a particular reaction? Normally, in a particular reaction, reactants combines to form product. The reaction must combine and reaches to a certain amount of energy. That energy is called activation energy. For a reaction happen, we need a certain amount of energy. That energy is called activation energy. When we use a catalyst in a particular reaction, the catalyst lowers the activation energy, so the reaction becomes faster. The presence of a catalyst increases the speed of reaction by providing an alternate reaction pathway that lower the activation energy. Because of lowering the activation energy, the reaction will be faster. When we are using a catalyst in a particular reaction, the catalyst just create an ambience for the reaction and they do not take part in reaction, and it can be reversed back. And we need to use a small amount of catalyst only. The effect of a solid catalyst can be improved by increasing its surface area. because if we increase the surface area, there is a more chance for effective collisions are there. Some common examples of catalyst and where we can use iron that's used in Haber process, that's manufacture of ammonia. Platinum is used in catalytic converter. Nickel, hydrogenation of alkenes. Next one, enzymes. Enzymes are biological catalysts. Enzymes are biological catalysts that catalyzes biochemical reactions in living organisms. These enzymes are proteins and can only catalyze one particular type of reaction. Enzymes, they are specific in nature. They react only for particular reactions only. For example, fermentation of glucose, we need enzymes. That enzyme is Zymer's. But there is certain conditions are there. At higher temperature or higher pH, enzyme will not work. That means there is an optimum pH and optimum temperature must needed for enzyme activity. In nutshell form, rate of reaction, several factors are there, depends on several factors. The factors that depends on rate of reaction are concentration, temperature, surface area or particle size, pressure, case of gases, light and enzymes. Thank you.